you have flashed the Raspberry Pi OS on your SD card, you can boot with the SD card, and this is already a few steps after the system has booted. So I just want to just kind of review what I did right after booting, because that I can't really record it. I can only record on my operating system, not on Raspberry Pi. So just pretend that you just booted and you're greeted with a couple of messages, and here I want you to make sure these settings are enabled. So go to Raspberry Pi preferences and go to Raspberry Pi configuration, and make sure you go to interfaces and enable VNC. This is a requirement because the VNC server that runs on Raspberry Pi starts disabled, the real VNC version. So once this is enabled, you see this icon right here, and before that the VNC icon was not anywhere. So once this runs, you'll be able to connect remotely like I'm actually doing right now. So before that, you need to be just connecting locally, and make sure this option is turned on. I also have turned on the SSH, so you can log in with say just a text interface that saves bandwidth, even if it is just across the room from your home's router. You may want to save some bandwidth. So there's other things you may want to change. For instance, do you want to boot to the desktop or not, and so on and so forth. The display here, there's also kind of a headless resolution, but what I did was I have a UHD display which is 2560 by 1440. It's too high of a resolution. Even if you're connecting the Raspberry Pi remotely across the room in your own home, you probably should lower the resolution. So that's the second thing, and it's under screen configuration. So let's just basically have these all displayed on one screen here. So yeah, the nice resolution of my UHD is nice, but I don't really want that resolution. If I'm remotely logging in through some cellular routers or cellular capabilities, I want as low as possible if I have to use the graphical interface. So here it is, the HDMI 1, and you can go and layout screen, HDMI 1, and go to resolution. So that's a native resolution of my screen, and I went down to 1024 by 768. I think that's still doable. If you went down further, it'll be a little difficult to operate, especially if you're looking at Python code. There won't be enough space to display a fair amount of that code. So let's see, that's not necessary. You can drop down to 60, but it doesn't really matter. It's the resolution itself. Okay, so once you have these two things done, and go over here, I have already connected. So you can take a quick peek at the your Wi-Fi address, the 190.0.190. So grab that number, and then just go to your home computer. So what I have, my main computer is a Windows PC, and I have this program, a VNC Viewer. So let's see, let's display this. Okay, so you can download it from real VNC. That's the same as the server running on Raspberry Pi. So you can download this. Mine is relatively old, doesn't really matter. So then you connect to it. This is that instance, and it'll connect and give you this nice bordered screen. You can do something about it. For instance, you can do full screen if you want, and this is already pretty good. You can remotely control your Raspberry Pi. And let's see what else we need to do before we can run some Python code and the SDI 12 adapter. So under programming, we just want to make sure that Python IDE here, it includes the Thonny, not the idle that's typically found on a Windows machine, but Thonny works fine. Okay, so let's see. Now you could switch to regular mode if you want, but this is already good. So the main window here is the code, and this is the interpreter. So if you want something 3 times 4, and that's interpreter. This is where you would actually load the code. Well, the code is not here yet because this is a new, freshly flashed Raspberry Pi. So what can you do in order to get the code over? Here's a bit of advice. Although Raspberry Pi is very fast, it's still not very fast in terms of a computer that you can use as a desktop replacement. I'm using a Raspberry Pi 4, actually a 400, the same capability as a 4 with 4 gigabytes of RAM, and it runs fine. But if you're trying to deploy with a Raspberry Pi 0W, that's a single core processor with I can't remember 1 gig or 512 megabytes of RAM, so it's going to struggle if you try to run it as a computer, as a desktop computer. So with that said, what I want to do is, if you have a fast Raspberry Pi, such as a 4B, you could certainly do development on it, but please try not to do development on the target, the deployment Raspberry Pi, which is probably low powered. Something could be a Raspberry Pi 3 that you have a spare, or maybe a Raspberry Pi 3A or 3B, or maybe a 0W. Try not to run anything on it, such as trying to edit the code. So this is fine. This is a Raspberry Pi 4. So I can actually get the code over, and then I can start working on it. So let me pause the video here, and I'll grab the code. Okay, so here's my blog, and you may have noticed there's actually a new domain name, and the old domain name still works, the liudr.wordpress.com, and this is a new one that I purchased, liudr, and this is the Electronic Solutions LLC, so that esllc.com. It doesn't really matter, the same address points to both. So once you get to the gadgets, if I just go to the home page, so under gadget, the USB adapter, and then scroll toward the bottom, and you'll have the before the firmware update, those are not necessary. So you have here some data loggers, and there's actually a let's go back here to the top. So the recommendation is for you to actually run the simple sensor detection and reading first, so you know that the whole thing works, and then you can certainly do sensor configuration, and you can also do a bus scanner just to scan and see what sensors are connected to your SDI 12. And this data logger is the most recent version. I don't really want to update it because it's already pretty complicated, and it is able to connect, as you can see the diagram, connect to multiple SDI 12 USB adapters, not just 2 but multiple, and each one having multiple sensors. So this is not the setup for most users. So if you want to download the software, that's fine, but don't make this your first stop. And I would do the very simple detection and reading first. Right. So the more practical versions, on the other hand, this one here, it runs with a single adapter. This is a more updated version, and I would basically recommend doing either one of these two. So let's go ahead and pretend we're going to download this program, and then we'll just copy paste it over to the Raspberry Pi. Okay, so I have gotten these two files. One is the reader, the other is the scanner. So how do I get the files over? Okay, so if you approach the top border here, you see there's a drop-down menu here. So a few options. This one is the transfer file, and to send files to the server. The server is the Raspberry Pi. Click Send Files, and to fetch, and you can do that. So just do the send files, and I'll be able to send the files over. Okay, I just got the files here, and I'll have these two. And let's see, I can use the entire folder, but I think these two files will suffice. Okay, so let's dismiss that. And this is actually within the Raspberry Pi. As you can see, you can't get it out. So I got a file sent over, and I can also use this send file to do send files from the Raspberry Pi if I want. Okay, so now it's already been sent over, and I can open the containing folder with a right click and left click that. So here it is. They're downloaded to my desktop. Okay, great. So I might be able to set it to download elsewhere, but that's fine. So if I minimize that, the let's see, the files have already been downloaded. Okay, so back to Thonny. I can load, and let's see, it's desktop. So let's do a reading here. Oh. Okay, so here's the code, and the result will actually show up here. So while you're looking at the code, probably it's best to minimize this so you can read the code a little more. And here's the code, about 50 lines, including some of these formalities. So I probably should add a Windows 11 over here as well. So let's see. This reminds me that the serial port module for Raspberry Pi for Python needs to be installed. So it's always useful to check that. So let's go ahead and run a terminal. I'll do pip list. So this lists all the Python modules installed on the Raspberry Pi. So this is all the default modules. So let's see, probably it's here. Let's see, yep, Pi Serial 3.5 B0. So the main version 3.5 has been around for a while. I guess they're pushing out slightly updated versions. So that Pi Serial is there. This is the module that connects Python to a serial port. Okay, and this is all here. All of this above is just formality, and then over here, this portion is the Python code looking at a list of serial ports, and it'll print out the list of serial ports and let you select which one is the Raspberry Pi. It's the SDI 12 USB adapters serial port. So there's some hint here. The SDI 12 adapter has a USB VID, that's a vendor's ID of 0403. So, okay. Come on, okay. Difficult to do that remotely. So basically over here is just asking for which port is the correct port, and then once that port is selected, the port is opened at 9600 baud rate, and then a little bit wait, and then a question mark, exclamation sign. This is an SDI 12 command to tell the sensor to identify itself. So if there's a sensor connected to the bus, let's make sure we only have a single sensor. Let's not have multiple sensors. We can't skip over these steps. This is a single sensor, just a simple read and display. So this is a serial port read. Because you have issued this command, the sensor is going to issue a response line. So that reads in the line, and this line is this line. So what this does is it removes the \r and the new line, and carry return the new line symbols that the response contains. So it's just nice to do that. And what this does is it's searching for numbers and characters in this line. Okay, so once it searches and finds some of these matches, the zeros group is the address, because the response to that is just basically an address. So it's asking the only sensor on the bus, what is your address? So the sensor will respond with a single character and 009, A through Z, lower and uppercase, depending on what the sensor's address was set beforehand. So it'll just respond with that, and then a carrier return a new line symbol. So they are removed here, and this search is kind of superficial, but it's useful to have a search here. And then it prints out that address, and it needs to decode because the serial port read is is ASCII, it's not Python 3 string. But anyway, now that the sensor address has been identified, this address contains that number, just that, and then you add an I here. So if the sensor address is 1, this reads a 1 capital I exclamation sign. This is an identification request to have the sensor identify itself what it is besides just the address. So this line, the next line, reads that response, and again removes the \r\n and then prints out the info. So after that, this command is issued. The amp command is the measurement command. So in SDI 12, there are two separate steps in order to obtain a measurement value. So the first step is to issue a measurement command amp, and then the sensor's response does not include the measurement itself, but it includes the number of values that it will return, and also how many seconds it needs to perform that measurement. A lot of measurements take multiple seconds, so that is necessary. Basically, after that, the sensor will usually send out a so-called service request, which is just its address with a new line symbol and \r\n basically. So that reads in the response of what type of measurement, how many measured values and how many seconds, and then the sensor will say yes, my address here. That means I'm ready to return the measurement. So the second step of the measurement is to do a D command, which extracts data. So this reads address D0 exclamation sign. So if the address is 1, it just reads 1D0 exclamation sign. So it'll extract the first batch of data. If there are multiple values, for instance, if the values there's so many values, say there's 8 values, and the D command cannot really return all of them. It'll return a portion of them, and then you'll use D1 to read the next batch, D2, D3, and if there's no more, then it just returns empty new lines. So this is assuming that we're only needing the first batch of numbers, and then we read that first batch of number as a response, remove that new line symbols, and then we're printed out. So that's very simple. After that, it just closes the serial port and it's done. The serial port is mentioned here because my USB adapter has a USB serial port chip on it, so it appears like a serial port, but it's connected to a USB. Alright, so let me get the adapter connected and also find ourselves a sensor, so we'll be able to run this code. Okay, I've just connected my SDI 12 adapter to the Raspberry Pi, and also I have an old Decagon sensor, so hopefully this will run. And since we're going to read the output, I'm going to expand this shell a little bit more. So let's go ahead and run it. Okay, so it's a simple reader, a lot of information here. So it has detected two separate serial ports. Well, the TTY USB 0 is typically the correct port, and also it says you should be comparing the vendor ID, and this vendor ID is indeed 0403. And this is another serial port. This is actually a Raspberry Pi serial port pins on the GPIO pins. This is not actually a USB serial port, so the vendor ID is 0. And so that's clear. You should select 0 here. So just hit 0 and enter. Okay, so it has found an SDI 12 sensor at address 1. So that is, let's see, if I go back to the code here. So this is the part where the serial port is listed and printed out, and then the user is asked to select which port is the right port. And then the port is open, and this command is sent over so that it reads back the address, which is 1. And then this command is cobbled together with address, so 1i exclamation sign. So that produces the sensor information. It's an old decagon sensor, 5TM. This is an inexpensive soil temperature and moisture sensor. And then after that, it sends the measurement and reads back the data, and apparently here is that data read back. So what this means is address 1, a number of 1.27. Well, you have to know what it is. You have to read this particular sensor's manual. This is the dielectric constant, I believe. So you can use this to calculate the soil moisture. Apparently I don't really have the sensor in soil, so this is almost like in air, which is 1. And this is 25.1 degrees Celsius, so that's more or less my room temperature. And so that concludes this really simple run, and I hope what I have showed you was the code is, well, it's understandable. This is the most basic version of it. It includes everything that's needed, some of these imports, and how the data is basically extracted by sending this and that. So if you already have the sensor address, you don't have to ask for it. And if you have multiple addresses, I can imagine you can send say 1M 1D0 and then 2M 2D0, 3M 3D0 for instance, and then you can also have all this in the loop. So you can loop, say, every 1 minute, 5 minutes, and 15 minutes, or whatever your cycle is, to keep extracting data. And instead of only printing the data, you can save the data to SD card, you can send it over to the internet, and the possibilities are endless. So once you have the data. Okay, so let's see, this is this one program. Let's open up the other program, which is a scanner. So this is also just another short program to show you how to do certain things. For instance, this one has more of these imports, but each import tells you what it is used for. So I try to keep everything clear enough. And again, some credits, and now we also have this 403 as a vendor ID. FTDI is the vendor that makes the chip I have on the adapter. So it does the same exact thing. Detects the serial ports and print them out, and then it's asking you to select the correct port. So once the port is open, waits for a little bit of time for the sensor to actually get power, the adapter to reset. And now we have a defined function. It's called detect SDI sensors, has a bottom address and top address. What this means is, would you like to detect sensors address from, say, 0 through 9? So this will be 0, this will be 9. If you know for sure there are no sensors with say lowercase alphanumerical addresses, you can just put a capital Z here, and maybe lower this, say let's say put a 0 here to include the numbers. So the rest of it is basically it's sending the information like this and looking for a response. So if there is a response, then and the information is displayed. So that means if you have multiple sensors, assuming that each sensor has already been given a unique address. If it hasn't been, then you need to make sure you you update the addresses. So let's run this and see if it works, right? And let's go ahead and run it. Okay, so all the credits, and here this is okay. So this time this one is detected as 0, but that's fine. So we'll select 1 here for the correct USB port with the correct vendor ID. Okay, so it's basically just scanning between 1 and lowercase z. Okay, so it has only found this one sensor, which is fine. Okay, there it is. So that's a pretty simple program. And the rest of the programs, as I said, they're data logging programs, so they're a bit more complicated to run. So maybe I'll cover that in another video. Thank you.